so we're doing more examples from yesterday. You guys already warmed up. We're checking them out. Benji, you were asking when I have 17 dx. Guys, wait a minute. Shouldn't this one have a plus c?
Yeah.
And shouldn't this one have a plus c?
Yeah.
And shouldn't that one have a plus c? So I have plus c1, plus c2, plus c3, but if I have 3 arbitrary constants all being added, what could I do? It's a new constant. So it's like I did plus c, plus c, plus c, and said they all combine to be a new plus c. It's an arbitrary constant. I have them separately, but I just combine them all together. Okay? Diane. U prime is for taking a derivative. We're taking integrals backwards. We are going to have to think about, there is some way of approaching U primes with integrals, but we're not there yet. Number 6, can I do a product rule? Nope. Chain rule? Nope. What would I have to do to solve it? Guys, what's the only operation in your integration rules that you can see? Multiplication? Nope. Division? Nope, unless they're trig, but that's like set to be there. Secant times tangent is the derivative of secant. But I can't do it unless I make it pluses or minuses. I have to FOIL. So I have to do piece by piece. So therefore you end up with, what's 3x minus 2 quantity squared?
9x squared plus 6 minus 12x plus 4.
And that was all being multiplied by 2x plus 1, right? So then we end up with, what, 18x cubed? You guys keep going. You already did it. You should have. Minus 24x plus 8x plus 9x squared minus 12x plus 4, all dx. But hold on, let's make our life a whole lot easier first.
Okay.
Let's combine like terms. Can anybody double check? I think something went wrong. Yeah, what went wrong? This one? 9x is squared, right? And 24x squared and 8. Good? Okay. So now integrate, he's alone. Negative 24 plus 9 would end up being negative 15. And then 8 and negative 12, negative 4x plus 4. Someone double check me. How's it look? Yeah? Okay. And now I have to integrate. Now guys, could I rewrite this separately? Integral, 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 18 out, 15 out, negative 15 out, negative 4 out. I could do that. But can we try to do it without?
Yep.
Let's do 18, x to the 4th, and just to make my life look nicer, over 4. Wait, pause. My ones who always wanted to do quotient rules before, can you bring down the 4 and see that it cancels and you have 18x cubed? Are we okay on that? Number next one, what would it be?
Cubed.
X cubed over 3, right? Because I have to have the 3 come down and cancel out. Who's awaiting for him? 15. Ooh, I could do something there. Minus 4x squared over 2 plus 4x plus c. Now, yes, we could rewrite him to be prettier. Hold on, double check. Looking good? So then I have what could I do? Well, I guess I could simplify, huh? 18 over 4 ends up being 9 halves x to the 4th minus 5x cubed minus 2x squared plus 4x plus c. Dun 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 dun. Cool? Questions? Why did I have to FOIL?
Because you can.
I don't have a product rule for integration. I have to just extend it for right now and make it pluses or minuses. And even in the future, I don't even know if like BC techniques could make that much simpler than that one had to be. All right, cool kids. I had a party down here. A trig party. What'd you do? Someone. Sine over cosine. What's sine over cosine? Tangent. Wait a minute. Why is that so helpful? Is cosine tangent a property? No. But is sine of x a property? Or integration rule? So you remember that T-proof stuff from last year? Come on, it was fun. I love T-proofs. No?
Or T-proofs.
Party poofer. Poofers. I don't know what that means. Poopers. You know when you had like sine, cosine, and you had to figure out, sine times tangent? That's not even what we were doing. Cosine times tangent. Remember this, kiddos, and we had to go down the T-proof and then show that it was true, QED? Or some of you did not have QEDs. You had like dinosaurs and bubbles and who knows what else that you were drawing at the end of it, but either way, we had to simplify our trig properties. Some of that simplifying is going to come in handy over here. So anyway, cosine times tangent, same thing as sine, minus the integral of cotangent squared of x dx. Oh no! I can take this one, right? What would for sine, the integral of sine, end up being? Negative cosine? Good, because derivative of cosine is a negative sign, so negative times negative is positive. Here comes the little munchkins. Over here, is that an integration rule? No, but there's a Pythagorean property that says cotangent squared can be rewritten as cosecant squared minus 1. Now guys, I'm a little terrified as to how bad we are at Pythagoreans. A, they're a forever card, and B, they're not that bad anyway. Anyone, tell me the easiest Pythagorean property of trig, real quick.
Equals 1.
Then why don't you know the other ones?
No excuse.
There's no excuse. If you know that one, you know them all. Wait, what? Why? Because they come from... Someone tell me, how do you get one of them?
Change it.
1 minus 9.
Get a 1 somewhere else. If I want a 1 right here, I need to divide everything by... I want a 1. But if I divide 1, I have to divide...
All of them by 1.
So I get 1 plus cotangent squared of x is cosecant squared of x. Got it.
Magic!
You've seen this. I showed half of you last year. Oh my goodness.
I've been listening now.
We should sue. How about the other one? Get a 1 somewhere else. Well, it's not there and it's not there. It must be here. How do I do it?
Divide it by cosine.
And what I do on 1, I do on...
All of them.
That's algebra, right? What do I get?
Tangent squared x plus 1 equals secant squared of magic.
Oh my
Not
goodness. Put a 1 somewhere else, Nick. So therefore, kiddos, if you were to look in your rules, you could see that the integral of cosecant squared ends up being what? Cotangent squared, technically a negative if you were like what no, not cotangent squared, cotangent, right?
Yes.
Hold on, double check. Derivative of cotangent is? Negative cosecant squared, so I put a negative because there wasn't one. Unless you had kept this in, then things would be a little different. And then I have minus 1 would be minus x plus c at the end. You could do minus c, but that's silly. It's an arbitrary constant. Just make it plus c. And I end up with negative 4 cosine plus cotangent of x plus c. Done, 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 done. Cool? Derivative of cotangent is cosecant squared, but there's a negative, which is why I have to put him in. So it'd be like a negative, negative is a positive. And then 1 has an integral of x, because derivative of x is 1. This is like the integral of k, is kx. Another way of thinking about it is it's 1 x to the 0, add 1, x to the 1 over 1. A couple different ways. All right, cool kids, let's get back. Let's get focused. All right, for my ones of you, and there have been multiple ones of you in each class, not just one, not picking on just you or just them, that say, I got to the bookwork and I had no clue. I understand that sometimes that is possible, but this homework, you better not dare use that excuse if I have no clue. Because we are going to literally, I am in your homework exercises, I am doing ones that are very similar to your homework. Come on, my amazing ones. Little bit by little bit. Okay? Here we go. We're going back to the easy stuff. Easy stuff, right? Show off to me. And the first one.
4x.
4x? No.
I'm joking.
X to the
4.
4
over 4.
over 4, or you could say times 1/4 plus x squared over 2 or times 1/2 plus, this is the one that somehow just confuses us the most, 5x, right? Okay, 5x. But everyone, what's going to be the new u prime that you're going to forget?
Plus C.
Plus C.
C.
Times 0.
No. Don't even say it. Don't even say it. Shush, 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 shush. Okay, the next one. This is a nice trig, right? Sometimes they're nice. Integral of secant squared. Remember, we can break it up. So technically, every time when I'm just having you start going right away, I'm really having us practice splitting them up. If some of you guys see that the negative would be prettier on the inside, you could say plus a negative. Either way. Integral of secant squared. Tangent of x, because that's whose derivative is secant squared. Plus integral of negative cosecant cotangent. Cosecant. You can always double check at the end. Be good at your derivatives. Derivative of tangent, secant squared. Derivative of wait. Who has a derivative of cosecant cotangent? Just cosecant. Now double check. Derivative, negative, cosecant, cotangent, derivative, 0, done. Last one. I haven't given you any rules about part C. And yet I expect you to be able to do it. Why? Because you're asking yourself the question, who has a derivative of e to the x, and who has a derivative of 1 over x. We've already answered 1 to help you out. Who has a derivative of e to the x? Got it. Who has a derivative of 1 over x? But, yeah, remember the whole domain problem? Absolute value. Okay. Homework is going to have some easy ones. It's not just going to be tricky. Letter C was a little unless you're like, wait. Integration is derivative backwards, right? Questions on any of these? We should be good. We've gotten more practice than period 1. Good? Okay. What happens in homework if they say something like, find the derivative and then find a corresponding
Formula.
integration formula? Oh dear. Guys, look at your green handouts really quick. What's on the left side of that whole handout?
Differentiate.
Derivatives. And then what did they do with those derivatives to get integrals? Backwards, right? Took the answer, it was the question. What do I mean? If I take the derivative, yes, maybe I want you not to forget all your derivative rules. But if I take the derivative with quotient rule, and if I figure out x squared minus x squared negative x squared plus 3 all over x squared plus 3 squared, if I say, yay, a derivative, then how can you say, yay, an integration formula?
Go back
How go back?
to the answer that they already used.
-1 over x.
Use the answer. The integral of the answer must take you back to the original. And this is just kind of giving you a peek at why there are so stinking many integration formulas, because it, in some senses, each derivative you could possibly find can be unique, so then it can have a unique integration formula. That's why there's that whole integration tables book that doesn't even cover everything. Guys, we should be masters at these, but just because I'm a little scared about you and fractional exponents. X to the what? 2/3. Be amazing, show off. How do I integrate that? Add x to the 2/3 plus 1 But that's hard. Do 3/3. So much easier, right? Still plus 1. So x to the 2/3 plus 3/3 would be 5/3. So I need to multiply by 3/5, right? I'm showing literally all my work just for those of you guys that can't do fractions in your head. I know you're out there. We still love you too. But plus 1, some of you are going to get lost in that whole common denominator thing. Just think, 2/3 plus 3/3, got it. 5/2 plus 2/2, depending on whatever the exponent is, okay? And then the easy way, instead of divided by 5/3, just make it a reciprocal. Your life's easier. How about, guys, let's not actually solve these because I know that we've practiced. I kind of gave you some like this at the beginning. How would you do this one?
Foil it first.
That's the only way you can, right?
Yeah.
So you would have to FOIL. Now, is that a possible integral? Yes. Instead of x's, there are what? No big deal, you can do it. No big deal. Different variable. Different variable, but you can do it. How about this one? Ooh, life just got exciting. All right, here we go. What do we do when they give us more than an integral, more than a derivative, and ask us to find, what's the actual term for what we're going back to? Antiderivative. What if they give us a point? What if they give us a point? And say, solve for the original function, and they don't want you to stay ambiguous, they don't want you to stick with the arbitrary constant, they want one exact answer, that's it, not a whole family. We alluded to this yesterday. We alluded to, if C is ambiguous, can it ever be found? Is there any case in which we would know what C was? Yes, but only when they give us an extra clue. Only when they give us a point. Because if you guys remember yesterday when we were talking about the family of antiderivatives graphically, wasn't it like one general function, but it was all these different vertical translations? Remember that? It's in your notes, all the different vertical translations. When they give you a point, they establish one specific answer. Same thing here. So what are we supposed to do? Well, we're supposed to go back to the original. At the end of the day, they want a y equals equation with the whole thing and no c in it. Well, to go from dy dx to y, to go from a derivative to its antiderivative, I need what? What mathematical operation? Integral. I need to integrate. But right now, dy dx that's not how it's supposed to look. How can I make it look better? Move the dx. Now, if you guys look at this, I'm going to make it 8x cubed, because really, that's hard. That's better. Does that now look like, if I take the integral of one side and the integral of the other, I might be going somewhere? Is it still where I want to go? What's going to be the integral? Let me zoom in. It's getting kind of small, huh? What's the integral of 1 dy? What's the integral of any constant? Constant times integral of k, dy or dx is k, y or x. What's my variable? What's the derivative of y? 1 dy dx, right? Integral of 1. Remember, if there's nothing there, there's a 1. How do I do that? Why don't I make it better? 1 over 8 is just 1/8 times, and then 1 over x cubed, I can make it x to the negative 3. Why did I do that? Because now I can use my power rule, right? Right? So then I have y equals negative 1/16. To make it easier for me plugging in, I'm just going to put that x squared down below. He's a negative exponent anyways. Well, that's all well and good, and usually we would say done, except we have a what? We don't have a c, but we do know a point. And what does that point represent? An x and a y. An x and a y. So what do I need to do?
Oh.
Find c by, when y is 0 and x is 1, well, c must be 1/16. It is the one function that has the constant of 1/16. So therefore, I know, not just the whole family, I know the one specific they're looking for, and they're looking for negative 1/16 x squared plus 1/16. That is the one time when solving an indefinite integral that you will not have a plus c. Because you did have it, but we could find it. How? Plug it in the point. Plug it in the point. Did I lose anybody? Is anybody still copying? Okay. What if, this is I think the last one for today, and we have a couple minutes. You guys are awesome. You ready? Last one. Well, you guys know how to do him, right? What would you do with that?
You know.
Nothing has a derivative of cotangent squared, but something does have a derivative of cosecant squared. Cosecant squared minus 1. We already did that. Okay. That was our last homework help. Translate. Life just got exciting. What would you do? Slope equals square of distance between point x, y, and the y-axis. The point negative 1, 2 is on the curve. What the crud are they asking? I didn't miss anything. This is all the question is. I need a formula, right? We're mathematical. We need a model. We need something to use, right? So wait a minute. Don't they have an equals just like staring me in the face? So what equals? And the slopes of a curve is the same thing as what function? Tangent line function, but we call it a what? Derivative function. So I can say slope, that's the same thing as dy dx. What else can I say? Square of the distance. How do I, what? So if I have some arbitrary xy, maybe it's good sometimes to visualize. And the y-axis, so this would be like 0y, right? How do you find the distance between 2 points?
Distance formula.
Distance formula. Oh wait, guys, hold on. It's just going to be, no. What's that distance? The horizontal distance. What's the horizontal distance? X. Mind blown maybe a little bit, but you could also, if you want to, you could say the square of the distance between the point x minus 0 squared plus y minus y squared, if you want to do it the hard way. That's just going to be 0. That's going to cancel out with that, and I'm going to end up with square root of x squared is x. All right, well, that was fun. Okay, so how do I solve this? How do I solve this for the original function? That's the one direction that's kind of missing.
X squared.
Oh, thank you. Thank you. Oh, ho, ho, too much. The square of the distance, the square of x. Hold on, pause, sit. What do I do? What did we do a second ago? And then when I end up with y equals 1/3 x cubed plus c, do I stop? Or do I notice that they give me a from which I am going to solve for my point. Cool kids, get out of here. Integration competition we'll do tomorrow. I didn't get to it today. That's okay. Some of you needed to catch up on how to integrate. Why are there baseball bats?
Haley, girl.
Combine? Yeah, but.
Yes.
Yes.
Huh?
Integration is sort of fun because I get to like work backwards and think about it. Yeah, I agree. For like just doing work. Alright, I'll see you at the game.
Yeah.
Where? Here. Okay, I might actually be able to. Depends on how. And I know I'll probably come either way. I was gonna say it depends on if I decide to actually spend a lot of time and go to bed early and do my gov notes ahead of time. Or if I decide to go.
Miss D, how come?
You're staying here today, right? At lunch.
For most of today, yeah. Benji, what's up?
Well, when you integrated, like, we added the plus C. We had the quadratic over the x squared.
Yeah.
How come when it says plus C, how come when did it one set? It would be like plus C, plus C, plus C.
Oh, I did explain that real quick, but think if you split it up, you're going to have all these different little integrals, right? They're all going to have like plus C1 for that part, plus C2 for the second part, plus C3. But if they're all arbitrary constants, well, I guess I could like figure out these plus 2, plus 3, plus 5, or I could just combine them all and say it's a new constant when they add together, and just say plus C.
Why not the BC? Like if you did like x plus x.
Well, think when you were solving for C equals 1 million ago, I could have solved for C like in one of those like C equals 2, and I'm like, okay, well if it was 3C, then C would equal 2/3. But then it doesn't matter if it's 3 times any constant. That would combine to be a new constant. So I could solve for the new one instead of solving for the old.
So when you add all the C's together, thank you.
All the arbitraries